Delighted to be able to begin. So we'll just continue from where we stopped last time, and we'll try to keep everything within 1 hour this time around. Maybe if there's interest on, if anybody wants, maybe it's speak or deliver, or maybe more hands-on kind of like class, maybe they can signify, they can find time to arrange that, so so I can do more live stuff. Okay, so I'll just go ahead and present my screen. So today we're talking about gas fees on the Ethereum blockchain. Um, so gas, by definition, gas is be required to kind of like perform any computation on the Ethereum blockchain. Hope I'm audible. If there are any issues with my audio, please just let me know. Let me know via the comment section.
Yeah, I can hear you over here. I hope we all hear you. It's clear over here.
Okay. So yeah, so like I mentioned last time, the Ethereum blockchain is kind of like a distributed computer, right? That gets to process information, and there's a cost for that processing, so it's not free. So for every operation, every transaction that has to be performed on the Ethereum blockchain, there's a cost. And one of the reasons why there has to be a cost is because, for example, the validators and other validators in other parts of the network have to invest their resources, right, to get this running on the network. So they have to buy computers, they have to buy electricity, they need stable and good internet connection to help process transactions on the network, help process transactions and run computations on the network. And in order to pay them for their efforts, the concept of gas was introduced to stop that, to meet that need. So the way it's so okay, so let me just put in a key points. So there's what we call gas and gas limits. It's a gas price. So that is how that puts it, the units. It's a measurement of the amount of work being done by a transaction, right? So a transaction might maybe take up to, let's say, 5,000 units of gas, right? The transaction is very small, or it could take 10,000 units of gas. If maybe it's a smart contract computation, maybe the transaction is interacting with smart contract and computations are being done. So the amount of gas needed for a particular transaction is way bigger, right? So gas just tracks the amount of work that a transaction is going to ensure. Then gas price is the price for 1 minute of gas, right? And not very audible for me. Okay, Mustafa. Mustafa, if it improves, let me know. If it doesn't, improve in the next, let's say, 2 minutes, let me know. So that we'll know if it's my network or it's on your end. Thank you very much. So just keep me posted. So, but I don't know. Am I very audible? Am I loud enough? I could be audible, but I might sound far away. So I don't know if it's all clear. I would appreciate it. But
it's all clear over my end. So I don't know if there is someone to confirm from his or her end.
Okay. Someone that's also confirmed well.
All right. Thank you.
Yes, it's clear from my end.
Okay, thanks. Okay, so as I was saying, so gas is kind of like a unit, like a unit of work, right? And the amount of gas um, tracks the amount of work being done by transaction, and um, each unit of gas has a price, and that price is determined by things like supply, demand, network capacity, and time of transaction. So what that actually means is the validators, in short, the validators are the ones, the validators or miners, um, which refers to the time when Ethereum was using proof of work. Um, but now Ethereum has transitioned to proof of stake. So in proof of stake, you call the parties who perform the transactions, the parties who process the transaction, you call them validators. In proof of work, you call them miners because they are literally mining, so they are performing work, so they are called miners. But under proof of stake, they don't really do a lot of, they don't do any mathematical lottery to get the right to process blocks. So they process block based on the amount of money they've staked. So they are called validators in that sense. So yeah, so the validators are the or miners are the ones that set the price, and they set the price based on network congestion. So if there is a lot of transactions moving through the network, right? It means since if they don't, they need a way, they will set the price in a way to um, reap, to maximize the profits from the high traffic, right? And also as a way to kind of like um, reduce the load on their end, like the amount of work they have to do. So it's just kind of like supply and demand law. So if there are so many transactions in network, the validators will increase their fee, right? In order to one, encourage more transactions and reap and profit as much as they can from the increased traffic. Then when there is reduced traffic on the network, right, the validators reduce the gas prices as incentive to get people to get transactions and people onto the network. So it's basic um, supply and demand. And again, prices are averaged, right? So each validator will set their price, and um, there are techniques and tools you use to kind of like detect the optimal price. So you can average prices from, so one simple trick people use it, you get the last block or the blockchain and check the price. So that's one way to know that's one very sure way to know the accepted price. So now I'm going to speak on something that's a little bit technical here. So the thing is, I would bring up my postman from our last meeting to kind of like describe this. So um, so if you notice, in this transaction, we did a demo where we set a transaction, a transaction on a dummy um, uh, blockchain, and if you notice, we specified gas price in the transaction, and we also specified gas. So your gas is technically your gas limits. So okay, I should increase the fund. Okay, okay. I think hold on, let me see if I can minimize. Hide it. Okay, I can't hide something. I'm just still for 2 seconds, right? Okay. So hope it's clear. Hope it's clear. You can see it now. Okay. I hope so. So okay, thank you very much. So if you notice, we specify the gas. So these are these are numbers that have been converted to hexadecimal form. because that's how the Ethereum network processes numbers. You send the numbers in the hexadecimal form. So I don't have to convert this. It's still a number, but it's in hexadecimal form. But you can I can put it in the chat for those who want to play with this. So you can check out rapid tables. So okay, tables. Yeah, so you can rapid tables. You can use that to do your conversion quickly. But note that this number is in way and not in it. So I would explain about that later. So Boy is like the smallest unit of. So Boy is just like you have Naira and Kobo, right? So you have it and Boy. So Boy is the smaller unit of Ethereum. So that's basically it. In our other classes, I'll find time to talk more about it. Okay, so for now, you set a gas price. So now the thing is, how do you set this gas price? And because you can set gas prices, you can, when the transaction eventually gets to the network, the miners or the validators, let me use validators in this case, the validators can prioritize transactions based on the gas price that was specified. So if you want a transaction to be processed very, very, very quickly, right? You can put a very huge gas price, right? So if you put a very big gas price, trust me, the transaction will be processed very quickly because it means the validators would benefit more from processing a transaction because the gas fee goes to the validators, right? But if you set a very small price, you will just find your transaction will just go to the network for can be there indefinitely, depending on how small it is. You understand? So that's one very technical thing about Ethereum transactions. So you have the ability to make a transaction be the first to be processed if you want, or you can, if the transaction is not top priority, you could just set a very small amount and allow it to be processed whenever anybody is willing to accept that price. So that's another thing about Ethereum. So now the thing is, how do you set this price effectively, right? So you set this price by one, looking at the previous price that was accepted for previous transactions. So you can take the last block or 2 blocks or 3 blocks, get the price that we accepted like for any of the transaction and averaging. So that's one way you can easily determine the effective price, the price that any validator will be willing to accept easily. But like I said, if you want to speed up the transaction, you can just, after you found out that optimal price, you can add a little more tick to it, right, to ensure the transaction is processed. So that's that. So recap, you can find out your transaction, the most effective gas price or the market rate by just looking at previous transactions in the blockchain and maybe either just reusing them or adding to them in order to get your transaction to process very fast. And the faster you want the transaction to process, the more you can add tip to it. So that's the effective transactions and how you can see the transactions. So that's that. So I'll get back to my slide now. Okay. So then we also have what's called gas limits. So gas limits, I think so this is the gas limit here. So your gas limit is saying the amount of computation you are telling the network the amount of computation that a transaction should take, right? The amount of gas that your transaction is going to consume, and you believe that's the limit. It should not be more than that, because it's difficult to accurately measure the amount of gas that a transaction would consume. So because it could vary from time to time and condition to condition. So instead of setting a specific gas, a specific amount of gas that your transaction will consume, you set the limits that you believe it should not go above, right? So you set like a range, a buffer that's enough to get your transaction processed. So if your transaction hits that limit, right, when it's being processed, your transaction will be reverted. That could mean probably your transaction is not doing what you think it was supposed to do. So it's also a protection against your transaction doing something inadvertently. So that's what we use gas limits. So set gas limits, telling the network that, okay, this transaction should not take more than, let's say, 1,000 units of gas from my calculation and from what I believe this transaction is going to take. And this is the price, just to specify, this is the price you're willing to pay for 1 unit of gas. So effectively, your gas fee becomes your gas price times that unit. So this then gives you the fee that you're going to be paying for that transaction. So that's how. So this is how transaction fees on Ethereum blockchain. Okay, let me take a question in the chat. Between, so Emmanuel says, Max is asking, between proof of work and proof of stake, which of them has more higher gas fee, or do have the same range? So the thing is, the gas fee is determined by supply and demand, right? And it's set by the miners of validations. So it's not, there's no fixed, and again, gas is something that is unique to Ethereum. You do have fees on Bitcoin, for example, fees that you pay and stuff like that. But in this context, like I said last time, Bitcoin is specifically money transfer, right? So the miners there too are the one that also set the fees for the transaction based on network congestion and traffic and stuff like that. Then, of course, in Ethereum, we have gas because on Ethereum, we don't just do money transfer, right? We also do computation. So gas is a way to kind of like accurately measure the amount of work that a transaction or a computation is going to consume. So that's how we do it. So the price, right, is set by the validators of miners and is determined by demand and supply. So if there's more transactions on the network, then if there's more transactions flowing in the network, then prices will go up. If the number of transactions on the network is lower, then the price will also go lower. And that will incentivize people to come up with the network to perform transactions. So I hope I've answered the question, Manuel. So yeah, so that's that. Then one other key feature of gas fees that also want to prevent abuse. So imagine there was no fee, right? People could send rubbish transactions, or people could just play with the network and just create artificial congestion, right? So a fee also helps to ensure that you use the network only when you really want to use the network. So that's another very important property of advantage of fees. So yeah, so that's it. So fees are incentives, right, for people to, one, help process transactions on the network. Two, they are need to prevent people from abusing the network, and three, they also have a property that helps to prevent you from inadvertently executing an operation that you did not you unintended transactions. So that's the case with gas limits. So those are like features of gas blockchain. Okay, so that's that for now. I would then move to the next. Okay, so I would move on to the very next topic, which is address, wallets, and encryption. So this is a very, very critical part. And again, please, if you have questions, before I proceed, if you have questions from previous from class, please just say them. I just wait for a minute um, before I continue. Okay, while I wait for questions, let me just proceed. So um, from our previous meeting, right, where we did a demo transaction. So we made it clear here that if the address of the person wanting to perform this transaction, so this is a legit transaction, right? And this is the address of the person that wants to perform this transaction, and this is the amount of money that the person wants to spend, right? So there, of course, this is the gas limits and gas prices, like we've explained. So what I'm doing is I'm deconstructing an Ethereum transaction for us so that we see like how this is really happening behind the scenes. So now this address, how do you get this address? How does this address kind of like uniquely identify you? And how do you control, how do you retain exclusive access to this address, right? So this is an address. This address is supposed to confer some rights to you, right? And you can exercise authority over everything this address does, right? So how does this really work? So that's what we're going to explain in this section. So so what I just showed you is what we call the wallet address. So this is the wallet address, right? And it uniquely identifies you on the blockchain. So it's like your home address or your bank account number for talking about fiat. And each address is unique to you and is the only means by which you can receive funds or be recipients of any action or any processing on the Ethereum blockchain. So so wallet addresses are hashed versions of the public key. Public keys are compressed and shortened to make it easier to send an address. So I would explain this now. So we can talk about public keys. So if we talk about public key, right, then there must be a private key. So that's how it works. So a private key, so that brings me to my first point here. So your private key or your private address, right, is part of a pair that gives you power over a wallet address. So this wallet address here, right, if to perform any action with this wallet address, you would need to be able to sign that this I am the owner of this address and I have power to perform operations with this address. And the only way you can prove that is by having a private key to this address. So your wallet is technically what we call a public private key. So let me step back here. Right? Really. So so your wallet is expand that. So your wallet address is a pair of your public and your private key, where your public key is the key that is accessible to everyone and is the address by which people can send you funds or make you recipients of any action on the blockchain. While your private key gives you rights to encrypt information to that address. So any action that you are executing in blockchain, a way for you to prove to others that you've been authorized, you are authorized, or you are the owner of that address, is by signing whatever action being performed in the name of that address with the private key, right? So this transaction I have here is going to be signed by the private key of this address, and I will show you the private key of this address now. So this is the private key of the address. So this is this progress. So this is the address, right? And this is the private key. So any transaction I initiate with this address, I have to encrypt it with this private key. So this private key should only be known by me and me alone, nobody else. Anybody that has access to this private key can then perform operations, any operation with this particular public key, and can also have access to any funds that could be in this public key, which is your public address or your wallet address. So your wallet is a combination of this and this. Your public address and private address. Okay, so let me take the question. Most people ask, what happens if I make a transaction among about 1,000 transactions and I have the lowest gas fee? Does that mean my transaction will take longer time or even not going to? Yeah. If if you have the smallest fee, then you risk the transaction runs the risk of not being executed. The transaction might be executed maybe when there is no activity on the network. Maybe when there's very little activity on the network, right? Then the price that you set on your transaction would now make sense to the validators or miners, right? So it will run at that time. So your transaction will run at the time. So sure, your transactions are run at the time when the price you set on them makes sense to the validators. So you can set a small price. It might not make sense to any validator right now, but when network activity has dropped, right, and the price now makes sense to them, they will process it. So that's the answer for you, Mr. Pam. So yes, so this is your public address and this is your private address, and your private address is used for signing your private transaction. Now, how does this work? How does your private address ensure that your transaction is secret, like no one else can tamper it? So that's what I'll discuss in the very next 2 points. So there's what we call the elliptic curve multiplication or cryptography. So we know that multiplication, you can reverse. If you are given two numbers and you multiply it, you can reverse the operation if you know one of the numbers, right? So if you say 2 times 4, use x here, so that's square. So if you say 2 times 4, you know it's 8, right? So if you are giving 8 and you are giving let's say a denominator or if you are giving, let's say, a factor, right? Let's say if one of the factors is 4 and you have to find the other factor, right? So what you simply do is say 8 over 4, find 2. So that way we found the factors of number 8 in this context, right? So we now have 2 and 4. So those are the factors. So that's how number multiplication works, right? So if you're given a number and you know one of the factors, you can find the remaining factor. And when people talk about brute force decryption, when people try to do any kind of like brute force decryption, what they are simply doing is finding a factor, right, that can divide a particular, because encryption has to do with, encryption is mathematics, and literally that's how it works. So when people do brute force decryption, what they're doing is they're looking for a factor, let's say 4, right, that can divide 8, right, so that they can get 2. When you now have 2 and 4, then voila, you have access to whatever um, um, resource was encrypted with this mathematical rule, right? So that's how encryption and brute force decryption works. But the beauty about the blockchains, they use elliptic curve multiplication. So the thing about elliptic curve multiplication is that you cannot reverse it. It's impossible to reverse elliptic curve multiplication. So it's a one-way multiplication. So when you multiply two numbers, right, with elliptic curve, let me use SAR now to signify elliptic curve multiplication in this context. So we get 8. This is just an example, right? It's a very simplified example. There will never be a factor. It's almost impossible to find a factor that will divide it to give you 4. So it's a one-way function. So forgive me, I'm using 4 and 8. These numbers are still one. But when you talk about encryption, we're not talking about very large numbers, right? Very large numbers. And elliptic curve multiplication is a one-way multiplication. If you multiply anything with an elliptic curve multiplication, you are not getting the factors back again. That's it. So now how do we use that in terms of addresses, private and public addresses? So this is how it works. So this is the formula, right? This is the formula for getting a public address. So this public address you're seeing here, this is how so this is the formula for deriving it. So let me do this. Okay, so this is the formula for deriving it. Where K is the public address, right? The big letter K is the public address. The small letter K is the private key, and the letter G is the generator point. So the generator point is the standard point on an elliptic curve, and that standard point is defined in the set 256K standard. So your step, your step 256K, I hope I'm pronouncing it properly, is a kind of like an accepted standard of functions and constants that we use in asymmetric encryption, especially elliptic curve encryption, which we call ECC. So the ECC is governed by your SCP-256K standard. So this G, right, which is the generator point, is defined. It's also another number, right? It's just another number. It's defined. It's a constant, and it's defined in your SCP-256K standard. So I don't want. I hope I'm not getting too detailed because this might just. I'll just keep things at a high level so that we don't keep the time. So yeah, so your G is the constant, right? Your K is your private address, and your small letter K is your private address, and your big letter K is your public address. Now, how do you get your K, which is the private address, right? Or private key. So your private key is generated random, right? So it's a random number, and how do we get it? Now, this is very critical. If the function that generates your private key is not completely random, it means that someone else can guess your private key. So that is very critical that we use functions that can give us uniquely random numbers to generate our key. If there is a flaw in the mathematical formula that gives you your private key, right? Then that flaw can be exploited to get your private key. So that was very critical. So how do we? So one technique we do is, so sometimes sometimes there are applications where they'll tell you to literally shake your phone, right? So what they do is when you shake your phone, they use the accelerometer, kind of like the they get the numbers that are being generated by your accelerometer. Or, there's some applications that literally would turn on your microphone, or rather, they would let's say, how do you get randomness? the sound in an ocean, right? Um, Decay of a radioactive element, right? What else? So there are very exotic ways to get very random things because the universe um, has a lot of properties that we can derive randomness from. How things sound, how waves kind of like. Anyway, let me not go too far. The thing is, just find a way to generate something that's uniquely random, right? Then the numbers we generate from that function becomes a private key. So once you get that, you multiply it by your generator points, right? And once you multiply by your generator point, you then get your public address. So I will point out that this your generator point is a point on your elliptic curve. Um, so I'm probably picking up a picture of elliptic curve, so that's I think I should put that here. So that's just so this is yes. Okay. So yeah, so this is an elliptic curve on a graph, right? And your G could be any point. So you see there are points here, P, Q, F, right? So your G is a point on this curve, right? So your G is kind of like a has a so what that would mean is I hope I'm not going too deep. So what that means technically is that your G is technically a pair, like XY coordinates, but I don't want to go too far. Your G is just a point on an elliptic curve and it's multiplied by your private key to give you a public address. So that's the relationship between your private key and your public address. So what that means is you don't really need your public key. You don't need to know your public key, right? All you need to know is your private key and your generator point. So your generator point is a constant, right? It's a constant on the elliptic curve. And so if everybody knows it, G is a so let me sorry I think I will update the slides for people who have it after the meeting. So that's um so it's very clean. Yeah. Okay, exactly. So this is your generator. So this is the value. So this value is the public value, and it's known all over the world. So it's not a secret, right? So all you need is this value multiplied by your private key thing, right? And you get the public address every time. So that's the relationship. Um, yeah. So I think that's all for so I think that's all for addresses and wallet encryption. So like I said, you then use your private key to encrypt your transaction, and on the Ethereum network, you could use now. Yes, so this is a beautiful thing, right? So any message you encrypt with your private key, right? It can be decrypted with your public address. So that's a beautiful thing. So anybody who has a wallet address or your public address can decrypt any message you sign with your private key. So the thing now is, so what that means is any transaction you send on the Ethereum network can be accessed by everybody and anybody, right? Because your public address is part of the transaction. So, but what signing your transaction does is that it ensures that whatever you have signed cannot be tampered with. So it's just protection against tampering. So nobody can tamper with what you signed, but everybody can see what you signed, right? everyone can see what you sign, but they can't tamper with it. So that's how wallet addresses and encryption, that's how they work on the Ethereum blockchain. So I will take questions now. So if anyone has any question, you just send them in. We have 10 minutes to be able to meet it.
Yeah. Thank you so much, Mr. Samuel. So please, do we have anyone with the question? You can unmute yourself.
Yeah. I think I think the network I think the internet is bad. I don't know if anyone can hear him clearly. Is it me or can anyone hear? Okay. So yeah, so okay. So
on the chat box and provide relevant answers. Is there anything you don't understand, is not clear, you need more, to place it on the chat box? Okay, yeah? Go ahead, sorry, please.
Okay. Can everyone hear me clearly? Hope it's not my network. Okay, that's fine. Yeah. So, any questions?
Okay.
Okay. While I was a question, I think I'll just point out something. Let me present the screen again. Yeah, okay, so I just to point out something. So like I said, I did mention multiplication a lot, right? But if if you notice, our keys are in like a polymeric form, right? So apparently you can't multiply things like this. I think I even showed the constant G just now, and it was also in a polymeric form. Yeah, so our constant G was it's also in a polymeric form. So the thing is, the number, like I said, the numbers are very, 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 very large. So they could be as large as, let's say, 2 raised to power, let's say 2 raised to power, let's say 80, right? Or that's like, yeah, very big numbers, like very, very large numbers. And of course, if those numbers are very large, they are not usable. So what we do is we then hash them, right? So a hashing algorithm takes data, right, and produces a string of 6 bytes from it. And one very popular algorithm is what we call fetcher. Or I think what they call it now is I know how to pronounce it, but the spelling is kind of like right. So using the hashing function, right? Any hash function to kind of like hash these big numbers to give us strings that have fixed bytes, right? So in the case of public addresses, we just take the least significant byte, like the last 20 bytes, for example, something like this, right? And just prefix it with 0x. So that's how the public address is derived. So check what we have here. You see You see your 0x, then you see your hash. So this is the least significant byte, the least significant byte of a bigger hash, right? But they just took the last 20 bytes and appended 0x to it. So that's how you get your address. In reality, your public address is a very big integer, like very, very big number. But those numbers can't work with them. They're not human readable. So that's why we then use this strategy to shorten them so that people could it could easily be moved around very easily. So I wanted to point that out. So the same strategy, the same thing goes for your private keys. So it's the same thing. So, but if you notice, your private keys are longer because they're like the full, not like cache. So, okay, so you said, okay, just as Amy, does it mean that more transaction increases, the more gas price? Yes, yes. So the more transactions we have on the network, the higher the gas price. Yes, because the how like the validators are using the opportunity to make as much money as they can, right? Because there's a lot of transaction and everybody wants to get a transaction processed, right? So you can set any price and people would accept it because they just want a transaction. If you don't like the price, like I said, if you don't like the price, you can set a low price and wait for when your price makes sense. Yeah, so the more transaction you have, the higher the gas fee. Okay, monetary state does this mean all it must start with 0x? Yeah, so all it addresses, yeah, all it addresses must start with 0x. So that's the standard um, protocol. If you try to send an address without 0x, your depending on the implementation, your operation might the result might just be undefined. So let's try it here. So you see there's an error. So I remove 0x, right? And immediately it records an error. Not converting value, right? So see the message. String must be hex encoded and prefixed with 0x. You get it? So that means all hex addresses must be prefixed to zeros. And again, and even values, like hex values, all your bit values are in hex formats. And because they're in hex formats, they must be prefixed with 0x. So not just addresses now, but also your values. Within your gas price, your tow address, so in this particular case, right? It's just for uniformity, right? Because this is actually a string, right? So your address here is just a string, right? So your 0x here is just to make everything uniform, so that you don't have something like this. So that you don't have something like this. Like this is now like this is not different from every other thing, right? So just for the sake of uniformity, you then just attend the 0x. So everything so that you have uniformity. But these are numbers. This here is a number, right? It's a hex number. So definitely that will be prefixed 0x. Okay, yes. So Oluwaseun is asking, but some transactions do fail due to insufficient gas fee, and gas fee will be deducted again. Okay, yes, that is MetaMask. That happens with MetaMask. So what happens is MetaMask would what do you call it? MetaMask would tell you the price, right? So MetaMask does not want you to execute a transaction, and the transaction would be there indefinitely. MetaMask does not have the time for that. MetaMask wants to quickly tell you that, okay, your transaction has been processed, right? So MetaMask will recommend the price for you and your transaction. In short, you cannot set, I don't think MetaMask no longer allows you to set price anymore. clearly happen. So MetaMask does not allow you they don't allow you to set the price. I think they hardly allow you to set the price. So I think you can still set the price. But if the price is lower than what is being accepted on the network at that current time, then it will just tell you failed and you try and send it to a higher price. But sometimes if you don't have enough if you don't have enough money, if you don't have enough eats, right, to process that transaction, I think that's when it actually tells you insufficient gas fee, when you don't have enough fee to process your transaction. If you have sufficient fee and you edit the price to something very small, I think it will still go, right? But your transaction will just go the network. So I think it's more of a problem of you don't have enough fees to process your transaction, or your transaction, or maybe you try to speed up, or maybe you have very little needs. You then try to speed up the transaction and you run out of funds. Yeah, someone's trying to ask a question. Yeah, valuable. Yeah, shoot.
Sorry, that was a mistake.
Okay.
All right. All right. Thank you.
Okay. Yeah. So so I hope I've answered your question. Yeah. So your transaction will fail most times because you do not have enough heat to process your transaction. So the amount of heat required to process a transaction is higher than your heat balance. Then yes, so this is a very important point. Every transaction on the blockchain needs heat. Is processed if you pay your transaction fees in heat. So even if you have USDC or USDT or any other whatever in your wallet, right? That is not what is used to process the transaction. It's the amount of heat in your wallet that is used to process the transaction. So if you don't have enough heat in your wallet, then your transaction will definitely fail due to insufficient gas fee. So assuming I mistakenly send it to another network, what will happen when I get my it back? If nowhere, where will my it go? Oh, okay. So the thing is, you can't send your it to another network except you use what we call a bridge, right? So there's something they call a bridge. So a bridge is a smart contract that allows you to move assets from one blockchain to another, right? So every except you're saying maybe you mistakenly send your it to another address. If you mistakenly send your it to another address, then that's it. You're not getting that money back. Yes. Then if your if you hit your gas limits, right? If you hit your gas limit, your transaction can be reverted. But do you get your it back? I'm not sure of that. I've not tried that out. I have to maybe test that. I don't think your it is reverted if your transaction fails. Okay, I think yeah. So if your transaction is reverted and fails, yes, your it will not be deducted. But I think that's something you have to test out. I've not tested it out yet. So so I hope I was able to answer your question. So recap, you can't send you can't move it from your from a Ethereum network to another network directly. It's not possible, right? You can only move assets within the Ethereum network. You can move assets to another network via what we call a bridge. So a bridge is an application that helps you achieve that. So apart from that, it's not possible. I'm sure maybe I think this question is coming from a Binance or a centralized network context. Emmanuel, if that's the case, please specify. So if you are doing transactions on a centralized exchange, for example, like Binance, then you're not dealing directly with the Ethereum network, right? You are dealing with a ledger or an application somewhere, right? So they can give you access to they can give you a withdrawal feature where you then specify the network you want to withdraw your assets to, right? if we send it to the wrong network, for example, um, then it's lost forever. Because except you have the private key to the address you are sending it to. So, for example, let's say if you're sending Ethereum from Binance, right, to a to a blockchain, let's say to what blockchain? Let's say Cardano, or let's say Ripple, or let's say Solana, right? So if you're sending Ethereum to that, withdrawing Ethereum to that blockchain from, let's say, Binance, if the address you are sending, if you have the private key to the address you are sending the money to, then of course the money will not be lost. What you simply do is you connect to that blockchain, right, and retrieve the funds with your private key. But the problem is, if you're moving that money to an address you don't have access to their private key, then forget it. That money is lost forever. You get, or it's lost to that address. The person, the recipient of that address, will simply receive the money in its balance, and of course, would not have any incentive to send it back to you. So that's very critical. Okay, so Emmanuel, shoot, you have it.
Yeah, yes, about what I asked. So it's about the address. I'm not talking about centralized exchange like Binance. I'm talking about what if sometimes someone might mistakenly send maybe you need it and you send it to a Solana network. So I know the money might not come back, but my question is, where will the money go? Is it that once the money reach the Solana, it will convert automatically to, if I send 1 ETH now to Solana network, will it convert to the equivalent amount in Solana? Or like, I just want to know, is it that the miners of ETH to take it or something like that?
Okay. So first things first, you can't send it from Ethereum to Solana directly, like I said. So that's not possible. What you are saying now is only possible from a centralized exchange, right? Or if you use a bridge, if you use a bridge on DeFi, a DeFi bridge, you get. So that's the thing. If it's from a centralized exchange, it's possible to send it from your wallet in a centralized exchange like Binance to Solana. Now, in the case of Solana, right? The thing is, yes, the asset will still be the asset will still be so the asset would be the equivalent of it on that blockchain. So we have what to call wrap tokens, right? So wrap tokens allow you move the native. So there's a difference between a token and a coin, right? So people can deploy a coin on any blockchain. So coin, you can deploy your own coin tomorrow. It's very easy. A coin is just a smart contract, right? But a token is the private, is the what do you call it? Is the native currency of the blockchain. So Solana, of course, does not use it. It has its own native currency called Sol, right? So if you're transferring it to Solana, so what your centralized exchange or your bridge will do is they will convert your ETH to the ETH equivalent on that blockchain. So the ETH equivalent on Solana might be WETH, right? WETH. That's ETH, right? Could be WETH or could be any other Ethereum equivalent to that blockchain. So that's what will happen. So the rest is so the owner of that address will simply just check his balance and see the ETH equivalent credited in his address. That's all.
Thank you.
Okay. So I think we are way past our time. If there's any other question, quickly shoot now. To around. Thank you very much. So I hand it over to host to take from here.
Thank you so much, Mr. Samuel. Thank you for an awesome class. We truly appreciate. I think there is no And the question again, you've done justice to the one we had. We appreciate. It's already weekend, and most people texted that they will not be available because of one thing or the other. Our videos are recorded, and hopefully you get them at due time. So thank you all for joining, and we'll be having a huge announcement come Monday. So stay alert, and we'll meet on Monday. Here is wishing you a beautiful weekend. Do well to go through what you've learned throughout the week, and know attendance is being taken every class and every session. So do well to avail yourself and be among the few that will be certified. You only get certified for being available and for contributing. Thank you so much, and wish you all a beautiful weekend. Bye-bye. Take care of yourself, and good night.
Bye-bye.
Thanks everyone for coming. Bye.